discussion on this ray optics, and this is lecture number. Lecture 12, 11, 12. We were talking about this refraction. So there are two small topics which I forgot to tell you. There was a topic of magnification due to a spherical surface in refraction. So I'm not going to derive that formula, but I don't think that formula is often used. So I did, but still I will give you the formula in study hours. You can remind me that. And there is a topic of mirage. So a conceptual based question is often asked from it. So I will talk about mirages as well. Okay? It's basically the refraction and all this. Anyways, remind me in the study hours. Okay. Other than that, I think we completed TIR last time.
Yes.
And we can move on to something new. And this is towards the end of the chapter. This is lens theory. So take the topic, lens theory. And today will be totally theoretical lecture, very basic stuff. And from next lecture onwards, we will probably do some sheets. Lens theory. Okay. And if you know about lenses, then actually they are not anything new. We have already talked about everything about lenses in a way, because we have talked about refraction when it goes from one surface to another, one kind of medium to another medium. Something like this, now we have already studied this. When the ray of the light is going from here to here, mu1 to mu2. Yes? You have a convex sort of spherical surface. What if I don't take this to be the whole medium, rather I cut it like this, and then I assume that this is mu1 again. Then I find a lens. Basically the same thing. And what principles will be used here? The same as before. How many refractions will occur here? Two. You remember the question that we did? You had a glass and there was water everywhere. And then we used to apply that mu2 by v minus mu1 by u equal to mu2 minus mu1 by r. We used to apply it twice because there was a virtual image after first refraction that used to act as a virtual object for the second surface. Same theory here, exactly same stuff. Okay? But we will derive some formulas for it. So lenses are nothing new for us in a way. So let me talk about lenses now. Please write with me. So a lens for us is just a combination of two surfaces. May it be plane or may it be spherical. A combination of two surfaces of maybe different radius of curvatures. Okay? It may be equal, it may not even be equal. So a combination of two surfaces, plane or spherical, of having in general different curvatures. Understand the meaning of curvatures? I'm basically talking about the radius of curvature. Whether it's big or small. In general, they will not have the same radius of curvature. Then what can be the example of such a thing? Can you think of any combination of surfaces? So let me take some examples. So I have mentioned a plane or a spherical, both. Let's take one of the examples. One of the surface is plane. I can take the other to be a spherical one. Then what can I make? Maybe something like this. What is this called? It's called plano-convex lens. Do you know this? So it's called plano-convex lens. a combination of two kinds of surfaces. What can be the other spherical surface? So I can have a plane of concave. Something like this. Are you making the diagrams with me? Please, I should not find any kind of diagrams with pen. All with pencils. Plane of concave lens. You may even have two surfaces which are same. Okay? I can have two surfaces which are same. Let me take one of the surface like this, which looks to me like a convex. I can have another convex, but it need not have the same curvature. Need not have the same curvature, does it? Do you understand how it is? It has a different sphere. It has a different sphere. Need not have the same radius of curvature for both. So it's a biconcave, like biconvex lens. What if the radius of curvatures are equal? Then what will I say?
Convex lens.
Equiconvex. I will call it equiconvex lens. And more often than not, if I don't say anything, then you should assume it is equiconvex. Okay? Good. If I have a biconvex, then what can I have? Biconcave as well. ऐसा माना है कि it should not have the same. Is it okay? A biconcave lens. What if I have a lens like this? A combination of a concave and convex. Maybe I have something like this and like this. It's called concavo-convex. It's also called convex meniscus. Or concavo-convex. What can be other than? What can be the other one? Convexo-concave, na? But how will I make it? Something like this. Can you imagine they don't have the same? It doesn't look like much of a curve, but it is a curve actually. So it's something like this. Okay? So what is this called? Convex and a concave meniscus, or convexo concave. Is it okay? How to understand which is the convexo concave and which is the concavo convex? Very easy to understand. Can you imagine if I make an extension of this, what will the circle look like? Not this, but rather. Let me change the color. Let me make it yellow. See, ये जो पीछे वाला surface है, it will have a circle like this. Huh? What about the other one? Like this? Which has a bigger radius of curvature? The first one, the first surface. The second one has a smaller radius of curvature. What about in this case? What about in this case? This will have this radius of curvature. This will have this radius of curvature. Which has a bigger radius of curvature? This one.
Second one.
The second one has a bigger. Do you understand the difference between them? It's all about radius of curvature. Anyways, Hopefully you have written the examples of all of them. As I have told you, if not mentioned, then it's all equiconvex or equiconcave. What do I mean by equiconvex, equiconcave? The radius of curvatures are equal. Okay? Also, without mentioning, I will make some assumptions as we go along. So, can I write the next stuff? You have written this? Anybody still writing? No.
For the convex meniscus also, could you explain it again? I don't understand.
Convex, ये वाले के लिए ये अगर देखेंगे, ये एक सर्कल है और ये एक सर्कल, which is a bigger circle, the first surface वाला. ये इधर देखो ना बेटे, ये first surface है ना, this acts as a bigger circle ना, and for this will be other way around. Anyways, so let me write the assumptions that we will use. If nothing is mentioned, then you should always assume these things. Assumptions. Now consider you have a convex mirror like this. Also, I should mention this. I will exclusively talk about convex lenses from here onwards. But don't think like the treatment is only followed for convex lenses. It is followed for every lens that I have mentioned. Okay? Every lens. I'm just taking one case and I'm explaining based on that everything. Is it all okay? Good. Then, can I write the center of curvatures for both of them? Let's say this is the surface 1, this is surface 2. It will have a center of curvature here somewhere. This will have a center of curvature here somewhere. Do you remember that when we used to find center of curvatures, then we used to always think of it from some reference point. What was that reference point?
Pole.
Poles. And if I make the poles here, this will be the O1 and this will be O2. In lenses, we don't say poles, rather we say optical centers. Okay? But then you will have to calculate every time with respect to different origins. Huh? Rather, we make an assumption, and this will be used throughout the discussion, that every time that we consider a lens, it's always so thin, it's very thin, such that this O1 and O2 are basically overlapping. And then we can assume that it's somewhere in between O. And we will always consider this O to be my origin. Always. Not O1, not O2, rather this O, and this is called the optical center. Is there any problem? So what is the assumption? That the lenses are thin. They are thin enough. So the first assumption is lenses considered are always thin unless otherwise mentioned. Okay. Unless it is said in the question explicitly that they are not, you should consider them to be. What is the second assumption? The second assumption is that, let's say you have a refractive index mu1 here and the lens is made out of mu2, then you won't have a mu3 here, you won't have any kind of different refractive index, rather we will assume that you will again have mu1 there. So this is mu1 and we will again consider this mu1 here. Okay? We will always consider that the lens is rather immersed in single liquid or single kind of material. You don't have different materials on other sides. Okay? So Ri is same on both sides of lens. I will also make the assumption most of the time that the lens is an equiconvex lens, the equi kind of lens, so that mod of R1 is equal to mod of R2. Most of the time I will also make this assumption. Under these assumptions, Acha, do you remember I talked about this first principal focus and second principal focus? Do you remember that? How was first principal focus defined to be?
The place where the rays converge when rays are coming from infinity when touching the first sun.
No. This is not on. What is F1 defined to be? Go to your notes and tell me.
The object was taken as
Object distance not at infinity. When object is placed at focus and you find your image at infinity, that is F1. And when the rays are coming from infinity and where they converge, that is F2. Idiots, you don't revise. यही होता है without revision. Anyway, so you have two focal lengths, and that is the case even for here. You will have two focal lengths. But if you take these assumptions, then you can assume that F1 is equal to F2 as well. Do you remember that you used to make this? You used to make this ray diagrams when you were little kids. For 2F1, 2F2, ऐसे लिखते थे. Huh? So I will not use that. I will not use F1, F2, but rather I will use F2F, F2F. Most of the time. Okay? Under all these assumptions, what you can say? This means F1 most of the time. Is it okay? And you should remember what is F1 and F2. Okay? Now some notes. This is the definition of equi concave or convex. Notes. The first note is that what was F2? How is F2 defined to be? When rays are coming from infinity, where do they meet? They meet at F2. That is the definition of F2 now. So if I take the case of convex lens, although I have not made any kind of ray diagrams, but hopefully you know some basics. If you have a convex lens and rays are coming like this, then कैसा होता है? Diverge होता है या converge होता है? Converge. ऐसा होता है ना?
Yes, sir.
Where will they meet?
Focus F2.
What focus?
F2.
They meet at F2. They meet at F2. Now is this F2 positive or negative for convex?
Positive.
What about F1?
Negative.
That's negative. Does it make sense to you? Let me make the other diagram and then you tell me what it should be. What is this?
Concave.
Concave, biconcave. And rays are coming like this. What happens?
They diverge.
Diverge. They come like this. Yes or no? They will never meet. But if I make their extensions backwards, then what happens?
They meet at F1.
They meet at F1.
No,
F2, sir.
The rays always meet at F2 when the rays are coming from infinity. So what is this?
F2.
F2. What is F2 for concave?
Negative.
Negative. So this is defining feature of concave. F2 will be negative. What will be F1? F1 will be positive. So let me write those things. I am going to erase the diagrams. Is it okay? So you should remember these things. Is for convex lens. I am just writing convex now, not biconvex, biconcave, anything. F2 is what? Convex lens F2 is what?
Positive.
Positive.
Yes, sir.
What about F1?
Negative.
Negative. What about for concave? What about for concave? What is F2?
Negative.
Negative? And F1 is?
Positive.
Does it make sense to you? Yes? Good. There was something else that I had to. Where's my DC button? Good, we have talked about most of the cases, most of the things that I wanted to talk about. And let it be. Good. So don't take it as a number one, rather this is the number. Okay? Now, one common thing that we have done in every discussion is try to find a relation. If I put my object somewhere, where should I hope to find my image? Every time we have found a relation between U and A. But for mirrors, we found something interesting, even that we found a diagrammatic representation. That was the ray diagrams. We will make a ray diagrams here as well. And try to see if I place my object at this position, what should I hope my image to be. But before that, I have to give you some standard rays. And what will the standard rays look like? So, some standard rays. Again, I am going to talk only for convex, but all of it also occurs for concave and everything else. If your ray is passing through optical center O, then it passes
without any deviation.
It passes undeviated. If you remember previously for mirrors, it was center of curvature, for which if your ray passes, then it goes undeviated. Now it's optical center. If your rays are coming from infinity, then they pass through focus. Then they pass through focus. Is it okay? If you place your object at focus, then what will happen? Goes to infinity. Goes to infinity. These are the standard three ways that you have to remember, and all the ray diagrams can be made just by three of them. Is it okay? Let's start with the ray diagram. Am I going too fast? You can say so. Can I start with the ray diagrams then? Convex lens. For convex lens, let's try.
उनमें सेंटर और ऑप्टिकल प्रिंसिपल का पोल
What are you saying?
पोल सेंटर वो लेबल है
ये है ऑप्टिकल सेंटर. यहाँ पे पोल you don't say pole, rather optical center. This is the focus. What is the problem?
ऑप्टिकल सेंटर.
And you can make the same thing here as well. Okay. So if you remember that we used to put our object at different positions and try to see where my image will be formed. So what are the possible positions? So let's ये O है. If you remember for mirrors we used to write optical center या फिर pole, focal length and center of curvature, but center of curvature was at 2f. So now I'm not writing center of curvature but rather 2f. Okay? So what are the positions? Maybe you are standing at infinity. Maybe you are just beyond 2f. Maybe you are at 2f. Maybe you are in between them. And then maybe you are at f or maybe between them. These are all the possible positions. Then I don't think I have to make the case when the rays are coming from infinity. You already understand it?
Yes.
Then let's take the case 1, which is beyond 2f. Case 1, object. I should not find any diagram by pens or without scales. Object placed beyond 2f. Is it okay? Place beyond 2f, then what will I find? Let's place my object here. A, B. What two rays should I consider? I can take any two rays and my diagram will be done. One of the rays we can consider going through optical center. Okay, let's take start. This is my one of the rays going like this. What is the other ray? Maybe passing parallel to principal axis and then goes to focus. This is not the correct one. I'm not getting the correct diagram because I'm doing by hand. But please do it by scales, you will get the correct diagram. Okay. So if you are place your object beyond 2f, then you are finding your image between f and 2f. What is the nature of the image?
Real and inverted.
What is the nature of the image?
Real and inverted.
Real, inverted. It should be diminished.
Yes, sir. Yes, sir.
Should be diminished, na?
It is.
But my diagram is so bad that it looks magnified. Ulta hi दिख रहा है। Not getting a straight line. बोलो।
In optics, you can use straight lines and shape.
I know that, but I wanted to make by अरे लाइन से करे अब इतना मेहनत करना पड़ेगा वापस
Take height.
How will the lines go? So something like this, right? Let me the colors. One of them is passing through the optical sector. Yes. One of them passes parallel to principal axis. Then through the optical. Yes, now it looks diminished maybe. Yes? This will be B dash, A dash, and I think that these are the rays that I direction. What is the nature of the image then? Real, inverted, and diminished. Is it all okay? This was case number 1. What could be the case number 2 then? Add 2f. What will you get then? Let's try to make y Good. This time I got it correct. What is the nature of the image this time?
Real inverted same size.
Real, inverted, and same size. Is it correct? What could be the next position then?
Between the
Between 2f and f. Do you see I find my image beyond 2f? Yes? Beyond 2f, and what is the nature of the image? It's real, inverted, and enlarged. Yeah, magnified. Real, inverted, and magnified. Does it make sense? Should I wait for some time?
Yes.
Yes, wait 2 more minutes. And I'll start with case number 4.
Sir, case 2 is object placed on 2f and image 2f.
Centimeters. That period is no centimeter. Let's start and then you will get correct. You can put to f as 2 centimeter and 2f as 4 centimeter. You will get the answers more simply. आवाज कौन सी क्लास से आ रही है? इंग्लिश की क्लास से।
Sir,
Can I start with case number 4 now? Where should I place my object now? At F. If I place my object at F, where should I hope to find it? Infinity. Do I have to take that place?
No.
It's all okay now? Then I am placing my object now between F and O. And what will I get this? Object is between F and O. Now what will I find? Let's make a diagram. So here you have the optical center O डाल दो दोनों को।
सर एक बार ऊपर कर दे।
जब से क्या कर रहे थे बेटा? ब्रेक पास।
नहीं सर, एक दो ही पेंसिल है सर।
तुम लोग के पास पेंसिल नहीं रहती है, इतने इडियट्स हो क्या? Can't bring your own pencil? Okay, I'm going forward now. So I'm placing my object between F and O. Let's say somewhere here, A, B. I can take any two rays. I will take the same two rays that I have been taking all throughout. One parallel to principal axis, going like this. One ऐसा. So let me make it correct. Do you see this? Will they ever meet? No. But if I extend them backwards, what will happen then? Yeah. Not beyond to it, but rather repeat. I will do it towards the let me make it correctly. I'm also getting beyond to it.
So it is vision effect.
हाँ वो होना चाहिए between F and two.
It is.
हो गया. Just. Good. What kind of image it is? Yes, and
Virtual.
it's a virtual image. That's the main point. Virtual
Erect.
is erect and magnified. So as we can see, for convex lenses, it actually goes the same way as a concave mirror bend. Most of the cases you find real images, but at the end you find a virtual magnified image. That's a very important thing. You're finding a virtual image, but it's also magnified. Now let's talk about concave lenses. What will I find there? So concave lenses, actually you can already guess that they follow the same trend as convex mirrors. And convex mirrors may be only considered two cases. One was when the object is at infinity, but that's a redundant case. You will find at focus. You will place anywhere the object, then where will you find? So let's try to do that. So I will make only one diagram. A diagram for concave lens will be what? ऐसा कुछ ये F ये 2F ये F ये 2F. Let's say I place my object anywhere I place my object, where will I find my image? So I can imagine the object is something like this, or maybe not. Although I can, but let it be. Let's say the rays are coming like this. The rays are coming like this. One is parallel to principal axis. How will it go? Passes through focus, and that is the extension. And then there will be a ray which is going through the focus. This thing. Then where am I finding my image?
Between F and object.
Between F and O always. What kind of image?
Real.
It's not
Sorry,
real.
sorry. Yeah. Virtual, diminished.
Yes, it's made out of dotted lines. One of them at least.
Virtual, erect, and diminished.
It's diminished. It's virtual and diminished. That's the main point. Where we found virtual and magnified. So that was a different thing here. And it's erect as well. So A, B, A dash, B dash. What is the comment? The comment is virtual, erect, and diminished. Actually, no. My apologies. A concave lens always creates a virtual image. Always. Is it okay? So it's kind of concave lens behaves like a convex mirror, and convex lens behaves like a concave mirror, sort of. At least the behavior is like that. The image formation. Is there any problem? Everyone is done, or do I have to wait some time? Okay, I'm waiting. These cases are. Do you want me to make that box that I made for mirrors? It's all okay? Please remind me in study hours that I have to talk about those things. Huh? Do you even remember what I told you? And today we don't have a study hours. 2 weeks. We don't have a study hours. Why is that? Yesterday we had oh, okay. Okay, I'll come in any study hour and learn this. Or if not, then I will discuss in one of the lectures. It will only take 10 minutes or 5 minutes. Is it done? So, can I go forward? We will do one derivation and then one problem, and then we'll discuss more in the next lecture. Can I go forward? So let's talk about we talked about by diagrams. If I put my object somewhere, then where will I find my image? But if I have a formula, that would be very convenient. So I need a formula or a relation between u, v and r. So let's try to find it. And this time I'm going to assume in general 2 different radius of curvatures. Okay? R1 and R2. And this is called the lens formula. The relation between u, v, R1 and R2 in general. Let's try to do it. So let's say you have a convex mirror again, or a convex lens again, You have this axis. Actually, I did not talk about this terminology, but hopefully you are clear. Na? This is principal axis, this, all those things, optical symmetry. Let's say it has a curvature C1 because this is surface 1, this is surface 2. And it has an optical center O, this is curvature 2. Center of curvature 2. Yes? And my object is placed somewhere here. My object is placed somewhere here. So this is my object O. But if I am going to say object O, then let me rename this thing. Let me call it P. It's still optical center, but I just renamed it. How many refractions? 2 refractions. How many images? Only one real image, but there will be in between one virtual image as well. Na? So let's say one of the rays comes like this, and then there's a mu1, there's a mu1, and there's a mu2. Na? Yes? What will happen? Refract. It will come like this. And actually, if you make the extension, then here you will find the virtual image I1. The virtual image I1. Does it make sense? That is after first refraction. But after second refraction, what will happen? The ray will come like this and it will create an actual real image I. How will that I1 behave as for the surface 2?
Virtual object.
That will act like a virtual object. Okay? So let's try to find a relation now. What is OP? What is OP?
U.
That's U. Very good. So this is U. What is PI?
V.
V. What is PI1? Let's call it V1. What will be PC1? That's radius of the R1.
Oh, sorry.
And what will be PC2? R2. In general. Is it all okay? When the ray hits the surface 1, then I can apply this refraction formula that relates B, U and R. Then what will the formula be? So for surface, for first refraction. For first refraction, can you tell me what is U? U is U. What is V? V is V1 for first refraction. What is R? Is it R1 or R2?
R1.
R1. This surface, no?
Yes.
This surface ka radius. Then, and from what medium to what medium you are going?
Mu1 to
to
mu2.
2. So I should write mu2 by v1 minus mu1 by u, that is equal to mu2 minus mu1 by r1. Is there any problem here? I am not putting any sign conventions for now on. Just writing bare formulas. Is it all okay? For second refraction, what will happen then? For second refraction, you go from what medium to what medium?
2 to mu2.
2 to 1.
From 2 to 1. So I should change these things? Yes. What is my object distance this time?
V1. V1.
That's V1. What is my image distance this time? That's V. So I should put my formula like this. Mu1 by V minus mu2 by V1, that is equal to mu1 minus mu2. By what radius of curvature this time?
R2.
R2, because it's a refraction on the other surface, huh? That's R2. Is there any problem on how I wrote the formulas? It's exactly like the same as before, huh? That question that we did, oh, if you remember, glass ball in water. Exactly like that. If I add the two equations, what will I get then? I think I will eliminate this V1, this factor of V1, adding 1 and 2. Yes, can I write it in one step?
Yeah.
You will get mu1 1 by V minus 1 by U. That is equal to mu2 minus mu1 by r1 plus mu1 minus mu2 by r2. Can you check if it is correct or not? Can you check? Or should I do it in step by step? It's all okay? Now this, I can take a negative sign out of there, and what will I get then? I can take mu2 minus mu1 common as well. I will get something like 1 by r1 minus 1 by r2. Something like this. Is it all okay? And then here we will have mu1 1 by 1 b minus 1 by u. Then I can write LHS in terms of 1 by b minus 1 by u, taking this mu1 there. I will find 1 by b minus 1 by u is equal to mu2 by mu1 minus 1 by r1 minus 1 by r2. This is the relation between b, u and r1 and r2. Okay, this is the relation. What if my rays are coming from infinity? If my rays are coming from infinity, then where do they meet?
At focus.
What focus? Which focus?
F1.
F1.
No, sorry.
They meet at F2, na?
Yes, sir.
They meet at F2. So, and most of the time when I talk about F2, I will write it as F, because F2 is something that we are interested in. So, when rays are coming from infinity, that means u equal to infinity. When u equal to infinity, then P is equal to F2. That is equal to F for now. And what will I get then? What will the formula be? 1 by F minus 1 by infinity is equal to mu2 minus mu1. Yeah. 1 by r1. This goes to 0. Then what is the formula of 1 by F? Bolo. 1 by r1. Most of the time when they talk about this focal length, you should understand that they are talking about F2. But in general, most of the questions for F1, F2 same bhi rahega, as I have told you initially, taking all the assumptions. If this is 1 by F, then can I substitute here and what will I find then? I will get 1 by B. Can you see that RHS of this and RHS of this is exactly same? Huh? RHS are exactly same, then the LHS will be same as well. 1 by B minus 1 by U is equal to 1 by F, and this is the relation between B, U and F. And this formula is called
Lens formula.
lens makers. Lens makers formula. And this is my lens formula.
So, if radius of both the mirrors are same, sorry, both the lenses are same, then from the first one, we're gonna get 1 by V is equal to 1 by U. How does that work? We will, because like
Because you
R2
are
minus
not taking into consideration the sign convention. The sign convention matters.
yeah.
So, paper लेके जा रहा है? पानी नहीं? अरे यार, तू गलत हो गया।
सर नहीं सर, अच्छा ही होगा, हम बच
अच्छा
गए,
हुआ?
हम बच गए
कैसे बचे बेटा? अभी
तो
तो
यार नहीं
नहीं
है।
जाना है पेपर लेकर।
ना, इसीलिए था
टिश्यू पेपर खरीदने जा रहे हैं।
अरे
कैसे जाओगे? नहीं है, कुछ नहीं है।
अरे इन्फॉर्मेशन इस्तेमाल,
పేపర్ పట్టుకెళ్ళా మళ్ళీ
अरे पेपर తీసుకున్నాను ఓకే సార్, इन्फॉर्मेशन इस्तेमाल, इन्फॉर्मेशन इस्तेमाल,
क्या imposition? क्या बोला idiot?
यस सर,
अरे वो बहुत बोली पेपर है, उसको वैसे यूज नहीं किया जा सकता है। Anyways, this is the lens maker formula. found a relation between u and v such that if you have some kind of object distance, you should always find the v. That's good. Now that we have the formula, let's try to try one question, and then we'll end the lecture. So. Take the question. This is given. Now try to do the question. Let me give you 3 minutes. Attempt the question. देखो पेपर वापस नहीं आया. अभी ये क्वेश्चन हो जाए उसके बाद बोलो. हाँ सब में. In all the formulas that I have boxed, remember that you have to apply the sign convention at the end when you do the questions. Always remember that.
So not for imposition.
क्या बोला?
Not for imposition.
Not for imposition. Hopefully you understand that lenses are made from glass. That's why mu g equal to 3/2 is given. Given that information, try to do it. बोलो. चलो. बॉटल भर के आया था ना कुछ देर पहले. क्या बॉटल पर्सन है क्या? सबका बॉटल भर के लाता है? तो तुम्हारे सबके पानी बांटता है सबको. क्वेश्चन करो क्वेश्चन. आंसर आया क्या? अटेम्प्ट इडियट. लगता ही नहीं. नाना स्टील. माइनस कैसे आ गया बेटा? कॉन्वेक्स लेंस है.
Sir, 17/20.
फोकल लेंथ इसका पॉजिटिव आना चाहिए.
Sir, 20/70.
When I talk about focal length, I already told you I'm most of the time talking about f2.
40 centimeters. Sir, 40 centimeters.
42
40.
plus 40. 40 is correct. Good. Plus 40 is correct. Negative तो आना ही नहीं चाहिए बिल्कुल भी. When we are talking about focal lengths, most of the time we are talking about f2, and convex lengths have f2 greater than 0. Yes. So you can't have that to be negative. क्या करें? Should I do the question? R1. R1, R2 is not mentioned in the question. When you put your lens in air, then what is the focal length? When you put it inside water, then what is the focal length? That is given, I think. Or you have to find something or the other. And then mu g and mu w is given. Okay, I am doing the question then. Which formula to apply?
1 by f is equal to
This formula, right? 1 by f is equal to this one. So, if I apply in air, then for air, what is the formula then? What is second medium? What? That's glass. Glass है. Mu g by mu air minus 1. 1 by R1 minus 1 by R2. We have no idea about this.
Sir, mu g by mu water.
Mu g by what?
Mu water. Mu of water.
Mu of water.
Again,
I am taking the case of when it is placed in air. What is mu g given to me? 3 by 2. 3 by 2 minus 1. And I think this focal length is given, na? 1 by 10. And you will get the factor of 1 by R1 minus 1 by R2 की value. This will be useful to us later. This will be 1 by 2, 1 by 2 to 1 by 10. That will give you 1 by 5, na? 1 by R1 minus 1 by R2 is equal to 1 by 5. Is it all okay? Now I will apply the same formula for water. And what will I get then? This time mu2 is again mu g, but what will be mu1? That will be mu of water. Does it make sense to you? The surrounding medium is now water. That's why I put mu1 as water. So will the radius of curvature vary? Depending on the, it won't vary, no? So it will be the same thing as before. And now I have to find this thing. But for this, what is mu g given to me? 3 by 2. What is mu r? Is it 4 by 3 minus 1? And this factor we found 1 by 5. And now can you tell me what is the answer? 9 by 8 minus 1. You will get something like 1 by 8 into 5, 1 by 40. 1 by f water equal to 1 by 40. That means f water is plus 40 centimeter. Please be mindful, it will always be plus. Yes? So I am not discussing anything more than this today. We will do some problems and some new things next time, and probably start with sheet number 6, which I will give you next. So you can stop the video and